Okay, lesson 45 is about conditional permutations. Permutations, remember, are arrangements of things in order, and we are learning how to count arrangements. And conditional permutations just means that there are more conditions on these problems than there were on the problems before. So this problem says how many odd counting numbers can be formed from the digits 3, 4, and 5 if no repetition is permitted. So the first condition on this problem is that we're talking about odd numbers. We only want odd numbers. Odd numbers end with an odd digit. We can only choose from 3, 4, and 5, so there are only 2 possibilities for the final digit. And we need to fill that in first. We need to deal with our conditions before we try to fill in any other boxes. So we're going to fill in the final box first. There are 2 choices for the final digit, either 3 or 5, because it's got to be odd. All right, the other 2 boxes can be either one of the digits that are left over, as long as there's no repetition. We can't use them twice. We can only use each digit once. So for the first box, there are 2 choices, and then the middle box has only 1 choice left because there are only 3 digits to choose from. So when you multiply those together, you get 4 possibilities, and you could even write out what those 4 possibilities are because there are only 4 of them. Okay, so either the number ends in 5 or it ends in 3 because it's supposed to be odd. So if it ends in 5, you can have the 3 and the 4 here, or you can have the 3 and the 4 like this. If it ends in 3, you can have the 4 and the 5 like this, or you can have the 5 first and then the 4. So those are the only 4 possibilities for this problem. The next problem has a lot more possibilities. We won't be writing all those out. Find the number of odd 3-digit counting numbers that are less than 600. So first condition is that we are dealing with odd numbers again. So we can choose from any of the digits, any of the 10 digits that we have, 0 through 9. But since this is an odd number, we have to end it with an odd digit. So there are only 5 of those, 1, 3, 5, 7, and 9. So 5 choices for the third box. All right, the other condition is that it has to be a 3-digit number less than 600. Well, 3-digit numbers that are less than 600 are going to start with 1, 2, 3, 4, or 5. So there are 5 possibilities for the first digit. We have to take care of that. We can't fill in the middle digit until we have filled in the other 2 digits because those are the conditional things. We got to deal with those. Now, this problem does not say there's no repetition, so we can use any digit we want for the middle box. So there are 10 digits in our counting system, so 10 of them. And now we just multiply those together, and that would be 250 possible counting numbers that are odd and less than 600 and 3 digits. All right, so 5 math books and 4 English books are on a shelf. How many permutations are possible if the math books must be kept together and the English books must be kept together? All right, so we can't just say 9 factorial. We have to keep the math books together and we have to keep the English books together. Now, we know that there are 5 factorial ways to arrange the math books. 5, 4, 3, 2, 1 for the choices. You can't repeat a book because a book is a thing that is actually there. You can't make it double itself. English books, 4 factorial possible ways to arrange those. We are going to multiply 5 factorial by 4 factorial to get the number of ways to arrange these books by keeping each subject together. The reason we're going to multiply is because for every single permutation of the math books, there are 4 factorial arrangements of the English books. So you have to multiply these 2 numbers together. So it's going to be a lot of different ways. Okay, there's one other possibility though. We could move the math books over here and the English books over here, and that's another 5 factorial times 4 factorial ways that you could arrange the books. So there are 2 possibilities of this scenario here. So you would multiply that by 2. So 5,760 ways to arrange these books if the math books have to stay together and the English books have to stay together. Okay, how many different 4-digit odd counting numbers can be formed if no repetition is permitted? So we have a couple of conditions here. It has to be 4 digits, and that means that the first digit cannot be 0. And then also, it's got to be odd, so the final digit has to be 1, 3, 5, 7, or 9. And there's no repetition. So first of all, we'll go ahead and fill in the final digit, which is 1, 3, 5, 7, or 9. So 5 choices for the final digit. So for the first digit, we would have 9 digits left, but we can't have 0. And we know 0 didn't end up here because 0 is not odd. So thankfully, we don't have to deal with that situation. The first digit has to be anything but 0, and it can't be the number we put in the final box. So there are only 8 choices. So not 0 and not whatever we put in for the final digit. So we've outlawed 2 digits so far for this first digit. So it can be any of the 8 digits. We have 9 left, but it can't be 0. So 8. The other 2 boxes can be any digit we want. There are only 8 digits left because we used 1 for the first digit and we used 1 for the last digit, and there's no repetition. So 8 for this part and 7 for this one. So 8 times 8 times 7 times 5. So that's 2,240 possible 4-digit odd counting numbers with no repetition. So Mario, Luigi, Peach, Toad, and Yoshi are to sit in a line. How many different ways can they sit if Mario and Luigi insist on sitting next to each other? All right, this is a little more complicated because there are lots of ways Mario and Luigi could sit next to each other, and then the other people would be arranged around them. So we have to deal with the condition first, Mario and Luigi. It's a little complicated when you have 5 boxes because in reality, Mario and Luigi could be thought of as one box because they're going to sit together. And if we go ahead and eliminate one of the boxes and just seat Mario and Luigi as a pair, then we can just seat everyone else around them and just look at the different situation. So if Mario and Luigi sit together, they can sit in this box, they can sit in this box, they could sit in this box or this box. So there are 4 ways, 4 places they could sit together. All right, so that we're going to multiply that by the way we can arrange the other 3 people, Peach, Toad, and Yoshi. And that's just 3 factorial. They could sit in any of the other 3 boxes. Remember, they are individuals. We can't repeat them. So for the other 3 boxes or the other 3 chairs, there are 3 choices for the first chair, 2 choices for the next chair, and 1 choice for the next chair. So 4 times 3 factorial would be the way to seat everybody if Mario sits on Luigi's left, let's say. But now we have to go back and count it again for if Mario sits on Luigi's right. So there are 2 times this many ways. So let me remind you again, the 4 tells me which box Mario and Luigi are going to sit in together. The 3 factorial is the way to arrange the other people. And then I'm multiplying it by 2 because I didn't take into account the fact that Mario could sit on Luigi's left or on his right. So that is 2 times 4 times 3 times 2 times 1, which is 6. So 2 times 24 is 48 ways. Okay, so that's one way to do it. Another way to do it would be still to consider putting Mario and Luigi in one box together. But instead of trying to think it all through like that, just all in your head, you could go ahead and seat them. You could say, okay, what if Mario and Luigi sit in this box? Then that's 3, 2, 1 choices for the rest of the people. What if Mario and Luigi sit in this box? That's 3, 2, 1 choices for the rest of the people. And this is just a rehash of what I just did, but it gives you more, it helps you see the situation more clearly. All right, if Mario and Luigi sit in this box, then there's 3, 2, 1 choices for everybody else. And if Mario and Luigi sit in this box, there are 3, 2, 1 choices for everybody else. So that's 6 plus another 6 plus another 6 plus another 6, and that's 24. And then, of course, we would go back and do Mario Luigi instead of Luigi Mario, because Mario can sit on either side of Luigi. And that would be 3, 2, 1. If we put them here, that's going to be 3, 2, 1. If we put them here, that's going to be 3, 2, 1 for everybody else. And if we put them here, that's going to be 3, 2, 1 again. So that's 24, and another 24 is still 48. And still another way to do it would be to use all 5 boxes. Get rid of the X, get rid of that, get rid of that. All right, and just go ahead and seat Mario and Luigi, all the different ways they can be seated. Okay, so you can have Luigi, Mario, and then 3 times 2 times 1. You can have Mario, Luigi, and 3 times 2 times 1 for everybody else. You can have Mario and Luigi here, and then 3 times 2 times 1 for everybody else, and so on. So if you want to go through and seat Mario and Luigi in all the ways they can be seated, that wouldn't take you a really long time, but it would take you a while, but you'd still get 48. So the point is, I mean, the big takeaway from this is that Mario and Luigi have to be seated first. You can't just start seating everybody else. You have to seat Mario and Luigi first and then deal with what you have left.